Hello everyone, welcome back to my YouTube channel. Today we are seeing the class 8 science chapter number 5 inside the atom, and this is the fourth session of the chapter. In our first three sessions already we have studied a lot about the atomic structure, research work by the different scientists, then the atomic structure in a detail about the proton, neutrons and electrons, atomic number, atomic mass number, and then the valency, electronic configurations, relationship between that. These things already we have discussed in our previous sessions. Today we are moving ahead. In that, the first what we are going to study is nothing but the isotopes. As already we have studied about the atomic number. Atomic number is a fundamental property of an element and its chemical identity. Means if any particular element's atom we are discussing, then the atomic number what we have is nothing but the fundamental characteristics of a particular element. The atomic number gives complete detail about the element, and that's why it is also called as the chemical identity of an atom. When we talk about the isotopes, the spatial characteristic we have for the atom, some of the atom in the nature, they have the same atomic number but different mass number, because till now what we know is a particular element is all the atoms are having a same atomic number and same atomic mass number or the mass number. But in some cases, some of the elements, they have the atoms with the same atomic number but a different mass number. Such atom of the same element having a different mass number are called isotopes. Example they have taken over here is a carbon. And why this is happening is just because of the difference in the number of neutrons they contain in their nucleus. The mass number of the isotopes are also represented by another method that we are writing as a superscript. So here you can see the carbon, C12, C13, C14. Three different kind of carbon atoms are possible. And 12, 13, 14 will be their mass number. No doubt their atomic number is going to be same. You can see here atomic number is the same, that is 6, only the mass number is different. And you can see here when we will calculate, we are getting the neutrons numbers are different in the different atom. That brings the difference in the mass number, and these kind of elements which are having a different atoms with a different mass number are called as the isotopes. You can see here they have taken the example of the isotope for the hydrogen also. So now here the number of proton, if I want to write down, it will be 1. Okay, here number of neutron 0, because total is 1 here. Now here 1 plus 1, this will give us hydrogen with 1 as atomic number and 2 as a mass number. Same way here for this, if I want to write down, it will be 1 here and 3 here. So 3 different types of hydrogens are possible. Let's write for the chlorine now. For the chlorine, if I want to write down the number of proton, let's make it for the proton. How many protons? 17. So 35 minus 17, 18 neutron will be here. Here, if I am having 17 protons, so it will be 20 neutrons. So this 2 different types of carbon atoms are possible, and that's why they are called as the isotope of carbon. Now, further we will go ahead towards the uses of isotopes. These isotopes are very useful in our life. The first one is that uranium 235 is used for nuclear fission and production of electricity, nuclear reactors or the nuclear power plants. Some radioactive isotopes like a cobalt 60 are used in a medical treatment of fatal disease like cancer. In the cancer treatment, cobalt 60 is used. Next, that is the iodine 131 is treatment of goiter, disease of a thyroid gland. In that, iodine 131 is used. The radioactive isotopes are used for detection of cracks or the leakage in the underground pipes, for example, sodium 24. Then radioactive isotopes are also used for food preservation from microbes. With the help of these radiations, they are killing the microbes present in the food so that it can be preserved for the longer time. Next one, the radioactive isotope C14 is used for determining the age of an archaeological object. Might have heard about the archaeologists when they are digging out and finding out something in the earth's crust, then they are saying that this particular article is this many years old. How they come to know? By using the isotope of C14, which we call as a carbon dating. Next, we have to study about the nuclear reactor. Nuclear reactors are nothing but the machine which generate electricity with the help of nuclear materials or the radioactive material. Nuclear reactors, you can see over here also they have mentioned nuclear reactor is a machine that generates electricity on large scale by using atomic energy. Nuclear reactors are nothing but where we are using the uranium 235. The nucleic or the atomic reactive or the radioactive materials are used in the nuclear reactors and they are producing a huge amount of energy and that is used to generate electricity. Uranium 235 bombardment with a slow speed of neutrons. And these neutrons are breaking this uranium 235 means it goes under the nuclear fission to form a nuclei of a krypton and barium with the 2 to 3 neutrons are also liberated. And that 2 to 3 neutrons will attack on a new uranium atom and they will also produce means it will go on continuously. And that's why the nuclear reactions are very dangerous. Further, this particular chain reaction, this is called as a chain reaction. You can see over here, one neutron is striking one uranium and it's breaking into a krypton and barium and it's producing a three new neutrons, neutron, neutron, neutron. So it can go to the another uranium, uranium, uranium. Means one will lead towards three neutrons, one neutron. This will lead towards three more. This will also go towards three more. This will also go towards three more. Means 1, 3, 9, 27. It will go on very rapidly. It will increase. And that's why this particular reactions are very dangerous. It should be properly controlled. Further, next they have given is about the moderator or heavy water is used as a moderator for reducing the speed of neutrons. And then next is to reduce the number of neutron by absorbing them. Rods of boron, cadmium, beryllium, etc. are used as controller. So these particular elements, they absorb the neutrons. The heat produced in the fission process is taken out by the using water as a coolant. Water is transferred into steam and that steam rotates the turbine and driven and it is producing electricity. Now about their India, they have mentioned over here in India total 22 nuclear reactors in 8 places are functioning. 8 places, total 22 nuclear reactors are functioning. Apsara at Bhabha Atomic Research Center in Mumbai is the first nuclear reactor in India, which went critical on 4th August 1956. India has large reserves of element thorium 232. Therefore, Indian scientists have developed a future plan for nuclear reactors based on production of a isotope 233 for the uranium and 232 thorium. So this is about the nuclear reactors in our country. And this finishes our chapter inside the atom.